Hello and welcome to another session in mathematics. In this session we'll be looking at quadratic equation, but before that let us look at the previous lesson. Welcome back. The objective of today's lesson is to teach you how to solve quadratic equation using graphical method, and we'll learn how to read roots from the graph and how to obtain minimum and maximum values, and also we need to understand what the line of symmetry is. Okay, so let us start with the graphical quadratic equation. Let us start with quadratic equation by graphical method. Okay, there are some steps we need to observe or follow while we are using the graphical method of quadratic equation, and one of them is to use the range of value of the independent variable, which is usually x, okay, to determine the corresponding value of the dependent variable, which is y. You use s to determine what? Y. S is the independent variable, y is the dependent variable, so you use your x, which is the independent variable, to obtain what? The dependent variable. Okay, so number 2, from the results you obtained in I, which is a range of value, then you prepare your table of value. Prepare your table of value. This is the table you use in constructing the graph. Okay, then number 3, you have to choose a suitable scale for plotting the graph. Okay, and then after that you draw the axis and plot the graph. Draw the axis, which are x-axis and y-axis, and then you plot the graph. Okay, then lastly you join the points. Okay, when you join the points, then it will form a very smooth curve. Okay, now I want you to note that the root of the equation at the point where the curve cuts x-axis. Okay, I said the root of the curve at the point where the curve cuts what? X-axis. Okay, assuming we have something like this. This is our x-axis and this is our y-axis, and we have a curve, and we have a curve. We determine the root by tracing the point of intersection of the curve and what? The x-axis. Okay, these points are the areas that will give us what? The roots of this equation. Okay, then I still want you to note that the curve we are talking about, it can be inverted and shaped, something like this. Okay, and sometimes it can be V-shaped, something like this. Okay, so the shape differs, and then I will say that the maximum value of y occurs at the peak or highest point of the N-shaped parabola. Let me say it again. The maximum value of y occurs what? At the peak or the highest point of the N-shaped parabola, while the minimum value occurs at the lowest point of V-shaped parabola. The curve of quadratic equation is usually in three positions. It's usually in three what? Positions. Okay, we have let me clean the board a little. Okay, we have the first curve to be in this form. This is our y, remember, and this is our x. Okay, so we have the first one to be in this form. Okay, then we have a point of intersection here. We have the second one. This is x, this is y, to be of the form. Okay, and then we have the third one. Here is our y, and here is our x, to be of the form. Okay, now for the first curve, we find out that the curve crosses what? The x-axis at 2 points, that is here and here. Okay, now these 2 points are the point where we derive the roots of this equation. Okay, the second curve, the 2 points are coincident. That is the point of their points are so close together that the curve touches the x-axis at just 1 point, which is just here. Okay, now this corresponds to an equation which has one repeated root. Okay, then we have the last one where the curve does not cut the x-axis at all. Now the root of an equation which gives a curve in this position is said to be imaginary. Okay, it's said to be what? Imaginary. Do you understand? Okay, now I want you to also note that the line of symmetry it divides a curve of quadratic equation into two equal parts, something like this. Don't mind my drawing. Okay, now dividing this curve into what? Two equal parts. We call this line what? Line of what? Symmetry. Okay, so let us move on and take an example on quadratic equation using graphical method. Okay, we have a problem here on the screen. It says we should draw the graph of y equal to 11 plus 8x minus 2x squared from the point where x is equal to minus 2 to the point where x is equal to 6, and then we should find the approximate root of the equation 2x squared minus 8x minus 11 equal to 0, and C, we should find the maximum value of y from what? The graph. Find the maximum value of y from the graph. Okay, let us start. For A, we have to draw the graph of y equal to 11 plus 8x minus 2xy from x equal to minus 2 to 6. So we start by substituting the value of x in this equation from minus 2 until we get to 6. Let us start. When x is equal to minus 2, y is equal to 11 plus 8 into minus 2 minus 2 into minus 2 squared, and y will be equal to 11. 8 times minus 2 will give us minus 16, and then we have minus 2 squared, which is 4. 4 times minus 2 will give us minus 8, and then when we add up the numbers, what do we have? We have 11 minus 16 minus 8 and that will give us minus 13. So when x is minus 2, y is minus 13. When x is equal to minus 1, y will be equal to 11 minus 8 into minus 1 minus 2 into minus 1 squared, and then this will give us 11 minus 8 then minus 2, which is equal to 11 minus 2 minus 8 is 3 minus 2 is 1. Okay, when x is equal to 0, y will be equal to 11 plus 8 into 0 minus 2 into 0 squared. So y would then be equal to 11 plus 0 minus 0, which is equal to 11. When x is equal to 1, y is equal to 11 plus 8 into 1 minus 2 into 1 squared, and y will be equal to 11 plus 8 minus 2. 1 squared is 1 times minus 2, we have minus 2. So 11 plus 8 is 19. 19 minus 2 will give us 17. Okay, when x is equal to 2, y is equal to 11 plus 8 into 2 minus 2 into 2 squared. Y will be equal to 11 plus 16. 2 squared is 4. 4 times minus 2 give us minus 8. Then 11 plus 16 is equal to 27 minus 8. We have 19. Okay, then when x is equal to 3, y will be equal to 11 plus 8 into 3 minus 2 into 3 squared. Y will be equal to 11 plus 8 times 3 is 24 minus 3 squared is 9. 9 times 2 is 18. So we have 11 plus 24, which will give us 35. Then minus 18, we have 17. Okay, when x is equal to 4, y is equal to 11 plus 8 into 4 minus 2 into 4 squared. Y will be equal to 11. 8 times 4 will give us 32 plus 32 minus 4 squared is 16, and 16 times 2 is 32. So this will just cancel this, and we'll have our answer to be 11. Okay, let's go over to the next slide. We stopped at x equal to 4, so we now pick x to be equal to 5, and we have y to be equal to 11 plus 8 into 5 minus 2 into 5 raised to power 2. Okay, then our y will be equal to 11 plus 8 times 5 is 40, then minus 5 squared is 25. 25 times 2 will give us what? 50. And this is 11 plus 40 will give us 51, minus 50 we have what? 1. Then when x is equal to 6, y is equal to 11 plus 8 into 6 minus 2 into 6 all squared. Y is equal to 11 plus 8 times 6 is 48, minus 6 squared is 36. 36 times 2 is 72. Okay, so we then have 11 plus 48, which will give us 59. 59 minus 72 will give us minus 13. Okay, now we've gotten all the values of y when x is from minus 2 to 6. So we then prepare a table. We have our x, and then we have our y. Okay, we have x to be minus 2, we have minus 1, we have 0, we have 1, we have 2, we have 3, we have 4, we have 5, and then we have 6. Okay, let's go back. When x is minus 2, y is what? Minus 13. We'll write it down, minus 13. When x is minus 1, y is 1. We have 1. When x is 0, y is 11. When x is 1, y is 17. We write down our 17. When x is 2, y is 19. We have our 19. When x is 3, y is 17. We have our 17. When x is 4, y is 11. We have our 11. Then when x is 5, y is 1. When x is 6, y is minus 13. Okay, so we've gotten the values of y. Now all we need to do is to go over to the graph and then plot this on the x and y axis. Okay, so let's go over to our graph. Okay, this is what the graph looks like, and then every bus in this graph is equal to 1 cm. This is 1 cm, this is 1 cm, this is 1 cm. Okay, now we are going to choose a scale depending on what we have on our table. So what's the highest number in the table? The highest number is 19. So every scale we choose will be in line with the highest number so that it can be able to contain the graph. So let's say 5 cm to 5 units on the y-axis, and 5 cm to 1 unit on the x-axis. Okay, so let us draw a line. Don't mind my drawing. When drawing yours, your line should be straight, and I'm not using a ruler, so I'm trying to make a sketch. Okay, so yours should be very, very straight. Then this is our y-axis. Okay, then we have here to be our x-axis. Okay, and this is our origin. Our origin is 0. Okay, and then the scale says 5 cm to 5 units on the y-axis. So it means we count 5 buses before we add our 5. So we count 5 buses from the origin. This is the first, the second, the third, the fourth, and the fifth, and then you mark it. So from 0 to here you have 5. You count 5 again, 1, 2, 3, 4, and 5. You mark it again, and that becomes what? 10. 1, 2, 3, 4, 5. You mark it, and this becomes 15. 1, 2, 3, 4, 5. You mark it, and that gives us what? 20. And the highest value of y we had there is 19, so we can stop there. Okay, for x we said 5 cm to 1 unit on the x-axis, so we count 1, 2, 3, 4, 5. You have what? 1. 1, 2, 3, 4, 5. You have 2. 1, 2, 3, 4, 5. you have 3. 1 2 3 4 5. You have 4. 1 2 3 4 5. You have 5. 1 2 3 4 5. You have 6, which is the highest number under the x-axis. Then here you have 1 2 3 4 5. This is minus 1. 1 2 3 4 5. Minus 2. 1 2 3 4 5. Minus 3. We'll stop here. Then for this we have 1 2 3 4 5. This is minus 5. 1 2 3 4 5. This is minus 10. 1 2 3 4 5. This is minus 15. 1 2 3 4 5. This is minus 20. We'll stop here too. Then we'll go over to our table. We have is minus 2. When x is minus 2, y is minus 13. Let's go and plot that. X is minus 2. This is minus 2. Y is what? Minus 13. So you trace it down, and this is our 15. So you count from here: 10, 11, 12, 13. This is the line of 13. You mark it and join it with that of 2. Bring this down, and this is the point. You mark it. Okay. Then when x is minus 1, y is 1. Okay. When x is minus 1, y is 1. This is minus 1, and this is the first box here. So we have here. Okay. Then when x is 0, y is 11. When x is 0, this is the point where x is 0, y is what? 11. This is 10. So here is our 11. Okay. When x is 1, y is 17. X is 1, y is 17. 15, 16, 17. So you trace it. Okay. And then join it to this point. Bring it down to 1. Okay. So this is the point. When x is 2, y is 19. When x is 2, y is 19. Y is 19. So we have 2. We trace it up. And this is 17. Remember, 18, 19. So trace it up, and this is the point. Okay. Now when x is 3, y is 17. 3, y is 17. It's now dropping. Okay. When x is 4, y is 11. 11. When x is 4, y is 11. We go up. This is the point where y is 10. So this is our 11. We shared it. Then when x is 5, y is what? Y is 1. When x is 5, y is 1. When x is 5, y is 1. So this is the point where y is 1. Okay. Then lastly, when x is 6, y is minus 13. Okay. This is the point where x is 6. So we trace minus 13 down. Okay. And this is the point where it is 10, 11, 12, and 13. We have it here. And then we need to join these points together to form the curve. So let's start. Start from this. Join this to this. Join this to this. Join this to this. Join this. Join this. Join this. Join this. And then lastly, you join this. So that is what the curve looks like. Okay, that's what the curve looks like. And then okay, for the B part of the question, we are asked to find the root of this curve. The root of this curve is the point where this curve cuts the x-axis on both sides. Okay, so this is the first point and this is the second point. So if we trace from here to here, this is -1, and you see that it exceeds -1, so we say it is what, -1.1. And then for this is 5 and it exceeds 5, so we say it's what, 5.1. So the roots of this graph are -1.1 and then 5.1. and then C, for C we are asked to find the maximum value of y, the maximum value of y, and the maximum value of y means this line, the maximum value of y, this point where y got the highest value, and it's what, at what, the point 19. Still check it on your table, you find it, it's what, 19. So 19 is the highest value of y. Okay, that's just all about the graphical method of quadratic equation. So having studied the graphical method of quadratic equation, provide the answers to the following question on the screen. Welcome back. So far we've been able to cover the graphical method of quadratic equation, we've been able to plot graph, and we've been able to find maximum value, and also find the root of a given curve. Okay, so do well to use the lesson notes on the platform for better information on the topic we've discussed. Feel free to drop your questions or comment on the comment section. Okay, till we meet again in our next class, stay safe and bye.